Hello there, welcome back to my channel, or welcome to my channel. If this is your first time to be here, don't feel awkward. I hope you're well. I am well. This week, I'm going to take you through the concept of data consistency and how you can use it in practice. So let's get started. So today I'm going to do, how many times have I said today? Have you been counting? Yeah, so today, again, I've said today. Anyway, count. I'm going to introduce you to data consistency. So, data consistency. Data consistency is about the way applications read data from your database. And it is more of how you scale your database, um, the procedures that you use to scale your database, and the techniques that help you in order to make sure that your database is not overwhelmed when you are scaling your databases. So I'm going to take you through an example that will give you a better understanding of what data consistency concepts are. There are two. There is a strongly consistent system, and then there is an eventually consistent system. And a consistent system just strives for everyone to see the same data at the same time. So let's say, for example, you have a blog and you have an analytics application on a certain database that checks on the number of clicks that are happening on your blog. So this number of clicks, if you have several applications that reads this number of clicks, your consistent system strives to make sure that everyone who is checking the number of clicks get the same data at the same time. But this is never the case, and this is what I'm going to show you in this session. Let's say you have an application. This, we are going to go back to our arts and craft. I'm going to just put a slab with this and that, and I call it an application, so something like a phone. And then you have a database, something like this, and you have done your best to make sure that your application writes to your database and also reads from your database. And you've seen that your application works well over time, and then you've started onboarding users, you've started rolling out, you've started how do they say it when people have their applications and they have like an MVP and taking it to the market, something of the sort. And then now when it goes to the market, you have now other users. So you have another phone. I'm going to draw it somewhere down here. So have another phone here that reads from your database, and then another user here. And things are well. Your database is performing well for some time because you have, let's say, 100 users who consist of your grandmother, your grandfather, and then your family of 10 plus their 10 children, that is 100. So you have 100 users. And then over time, you continue having more and more users. And that starts overwhelming your database. So here's your DB. It starts overwhelming your DB, and you have identified that people are mostly reading from your database and not writing. And you want to be able to make sure that when people are reading from your database, the database is not, your primary database is not overwhelmed. The resources, for example, the CPU. So overwhelming of the database, I mean consuming most of the resources so that your database is not performing well. So not performing well, I meaning it takes a lot of time to write data onto your database or reading data from your database because there is a lot of reads and a lot of writes that are happening to your database. So as a normal person, what you're going to do is maybe vertical scaling, increase the size of your database and the compute. Basically, you're saying that you're just going to be throwing money onto it, and it becomes a bigger database and a bigger database. But the architecture of your database sometimes, the architecture of any system sometimes just reaches the end, and the challenges that faces that system becomes more complicated than the money that you have. So even though you increase the size of the system, it will still perform poorly because you have maybe a lot of data that need to be read and sorted, and you need now other techniques that will help you. So this technique will be replication of your database. So we're going to go into DB replication. So now I'm going to draw this. I don't know how to copy and paste. Do you know how to copy and paste from this app? No. So let me draw it again. So I have my database here. And I'm going to call this one the main. This is our main DB. And then you have users. So user 1, who is writing and can also read. But whoever needs to read also can read from another DB. So you're going to create another database here. And this one I'm just going to call it secondary DB. Maybe let's say this DB is in one region, region 1. You can say, oh, I'm going to have another replica. So this is replication. DB, the main DB in region 1. So the main DB in region 1 replicates the data into the secondary DB. Let's assume this also is on region 1. Maybe if it is AWS East, US East 1, the one that the one that was off some time back and everyone was complaining. Yeah, so whenever this user here writes data onto the main DB, that data is replicated to the secondary database. And then now you can say maybe there is user 2 who just wants to read data, will be reading data from there. So read. So this helps because the computation that is needed to read data from your database is now offloaded to the secondary DB. And then now the performance of now the main database is not affected. Yes, you can read from the main database, but you can also read from the secondary database. And writing, you can only write to the main database, because if you write onto the two different databases, it may be a little more complicated to synchronize the data. So you can only write to the main database. That's why you see the user 1 I've put here, read and write. You can write to the main database, but user 2 can only read here. If the user 2 wanted to write, user 2 would write to the main DB. So write. So let's say that is in region 1, and maybe you have also users in Africa. So you want a database that is close to them so that there is no much latency whenever they are reading from your application. So you create a database in Africa. Maybe let's call this region 2. And this is another secondary DB. And your main DB also replicates into the secondary DB replication. And then now you have user 3 who is in Africa, can read from the DB that is in region 2, and whenever they want to write, they write to the main DB. So this kind of architecture is helping you more so when your application does more of reading of the data than writing of the data. For example, if it is a blogging platform or social media. Social media, most people consume the content than creating content. Maybe TikTok is where everyone is creating content, but if your application is structured in a way that, or the purpose of your application is more of reading than writing, then this would be a good architecture for you, so that you don't overwhelm your primary database with reading and writing for all the users, and you don't also spend a lot of money just scaling upwards and you are not seeing any performance improvements. So what you could do is have replicas of your main database. Whenever there is change onto your main database, replication happens into your secondary databases. And your secondary databases, you can decide that they are as close to your users as possible. So here we're talking about region 2 being in Africa, so that when I want to read, for example, your newspaper from your blogging site, the read happens in a database that is in Africa, and it doesn't take a lot of time for me waiting for your pages to load or your content to load on my phone or on my application. Yeah, so when you have such kind of a system is when now we start thinking about consistency of data. Remember, you are writing on to only one database, and then the data that you write there is replicated into the rest. This thing doesn't happen instantaneously. It doesn't happen that at 10:30 you have created a blog. That blog will appear onto all the other secondary databases. That doesn't happen that way. Oh, I think I am blocking someone somewhere. Let me move my face away from there. There are two types of consistent system. There is a strongly consistent system, and there is an eventual consistent system. So a strongly consistent system means that every request returns the most up-to-date value or an error if it can't. So let's first look at a strongly consistent system. I'm just going to write strongly consistent somewhere here. Strongly consistent system. Instead of system, I'm going to say reads, because it is reading from the database. So when, let's say, you have a blog, let's say, what's the news that is happening? Let's say, yes, the mayor of New York has been elected and is a born Ugandan, Indian, blah, 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 and so forth. And everyone is talking, blah, blah, is a Muslim and so forth. All that. But you've decided that you're going to write a blog about it. I think that is not... Let's use another example. Let's say you have an analytics system that looks at your blog that you've written, let's say about that mayor, and the value of the number of people who have read your blog is, let's say, X. So you are tracking the counts of read or the number of views. So you have, let's say, the number of views on your database here. Let's say you had views equals to 20 views, maybe in the first minute when you published. And this was replicated here onto your secondary DB. So views equals to 20, and also this other one in Africa, views equals to 20. And then you have one more person who comes and reads your blog. So the one person when one person comes and reads your blog, your value will be updated from 20 to 21 here. So for a strongly consistent system, for every request to read the data from secondary databases, the value that is returned whenever the secondary databases are this one here, and this one. So whenever there is the user here requests to read from any of these databases, maybe user 2 or user 3 requests to read from any of those databases, whenever they are requesting to read from a secondary database, the secondary database will return the most up-to-date value, or it will block, or it will return an error if it can't return the most updated value. And the most updated value, I mean the most updated value in the main database. So if you want to, let's say now that we have views here in the main DB being 21, for a strongly consistent system, for these other views in secondary DB, this one here that is 20, and this one here that is 20, whenever the user 3 and user 2 want to read from their secondary databases, they will not be able to, because the reads are strongly consistent. So the reads will wait until the values in secondary databases are updated to the value in the main DB. So when this is updated to 21, and this one here is updated to 21, then user 2 and user 3 are able to read these values. Then for an eventually consistent system is the opposite. So let's say for an eventually consistent system, I'm going to wrap this and then I put it as eventually. So for an eventually consistent system, whenever another person comes and reads your blog, and let's say the view counter has gone to 22, whenever user 2 tries to read the number of views, they will see the value 21. And user 3 will see the value 21. Their request to read the number of views will not be blocked, or they will not get an error. This is because the system allows them to read, and eventually they can read the most updated value. So when replication happens, and then the number of views in the first secondary DB in region 1 is updated to 22, and then the number of views in region 2 is updated to 22, then user 2 and user 3 will read the values for views being 22. But remember, as from the beginning, user 1, whenever they read from the main DB, they were seeing 22, and user 2 and 3 were seeing 21. So for an eventually consistent read, once data is updated, eventually read requests return the most updated value. But if the replication has not happened, you can still see the value that is in the DB. So that is eventually an eventually consistent read, an eventually consistent system. So how do they work in real life? Let's say you have a stock exchange or stock exchange app, and it is distributed in the same way. So let's say here we have stock exchange. So the price of the stock, whenever it changes, you would not want someone who is in region 2 using a replica DB to see the old value of the stock, old stock price. And for that case, for a stock exchange system, you would prefer to use a strongly consistent system. Then another example for an eventually consistent system would be view counter. Then you will be blogging So where you have your blogs, social media. So this would be, you would use eventually consistent system. Yeah, so for a strongly consistent system, you should look at also the drawbacks. So for strongly consistent, that means that it's going to be a slow system, because if you can't read from the replica, that means that you have to wait for the replication to happen. But you're taking that drawback while making sure that the values that you read are as accurate as they are from the main DB. So for example, in stock exchange, it's better you read an accurate value later than reading a wrong value. Then for an eventually consistent system, you need to you're going to read the values quickly from your replica DBs, but you also don't care about the accuracy of your data, and you're comfortable in getting the accurate data over time. So yeah, that's what I have for you about consistency, data consistency. Until next week, hopefully you've learned something this week from me. Until next week, take care.